I'm recording.
This video is about quadratic functions and specifically completing the squares. So what is the story about completing the squares? What you get usually is a quadratic function looking like that, f of x equal to ax squared plus bx plus c. And then we would like to put that in this format. Y is equal to a times x minus h to power 2 plus k. And why is this format important? Later in calculus sequence, you will see the applications of this format. But for now, for pre-calculus, what is important for us is to find, again, quadratic equation is the graph of quadratic equation is a parabola, and what is important for us to find the minimum of the parabola if it's looking upward, and the maximum point of the parabola if it's looking downward. And so this is going to help us do that, because if you look at this point over here, for example, when a is bigger than 0, it's when the values of x that makes this thing minimum. And how do we achieve that? The best way of achieving this is when this squared is the lowest. Is this positive number is the smallest. And that is achieved when x is equal to h. So looking at that format, I see that the h is going to give me x value for the vertex, and if I plug in h into this format, I get 0 for this, and k would be the y value for this format. Again, for a less than 0, I'm looking at a point whose y value is the maximum, and looking at this format, a being negative value here, and I want to subtract the smallest amount, because negative times squared means a negative value. I want this thing, the entire thing here, to be minimum. And to make that minimum, this has to be 0. That means x has to be equal to h. So x equal to h again. And then if I plug back in h in here to find y, this part is 0, and y is going to be equal to k. So that's the importance of a quadratic, this format of the quadratic functions when we completing the squares. The next thing is we want to figure out if they give us one function in that format, we want to be able to convert it to the completed square form. And so how do we do that? So I would try to drive the formula first for you guys. Let's see. This is the format given to me. This is my desirable format. And I want to figure out the value of h and k in the desirable format. A is already given to me, right? This is, since this side, this side is given this value, and this value, even though right now I'm using parameters in the problems that you're going to encounter, these values are given as real numbers. Now, how do I figure this out? They don't look the same, so what I do is I convert the part that the format that I want into the format that I have, instead of going the other direction. So if I convert this side, I need to get rid of this x minus a, the binomial term that I have in here, and make it into the quadratic form. So use a binomial expansion. That's x minus h to power 2. That is the first one to power 2. 2 times first one times the second one. There is a negative sign with the second one. So it would be 2 times hx plus the second one to power 2, which is h squared plus h squared plus k. Now this is going to be, and distributing a through, I would get a x squared minus 2a times hx plus a h squared plus k. Setting it equal to the values that I have, I will see that the coefficients of the like terms have to be the same, and in this case for x squared they are the same. That was how it was designed. Now the next thing is the coefficient of the x should be the same, and the last thing, the constant on both sides should be the same, right? And this entire thing is the constant. A h squared plus k is the constant. So this would not give me any information, new information. This part will give me new information. Let's write that down. So b is supposed to be equal to negative 2ah. This coefficient, and that gives me that h, and I'm solving for h. Supposedly when we get the green things, we get all numbers a, b, c, and a, b, c in there. So h is equal to b divided by what multiplies h. Or the other way, h is equal to, negative sign comes up. So we're done finding h. The next part is to find k. Now, how do I find k? I have to set c equal to this entire thing and figure out how to find k. So c is equal to a h squared plus k. I like to keep it as one unknown in here. And h I already solved for the parameters that I have. K is the one that is not, so k should be the only one that is not solved for for those parameters. Let's plug back in h in here. And then solve. First to power 2, negative b becomes b squared, and 2a to power 2 is 2 to power 2, a to power 2, 4a squared plus k. Solving for k gives me, and this entire thing is b squared divided by 2a. So it would be c minus divided by 4a, minus b squared divided by 4a. So now I can do the conversion from this format to this format using h and k that are like this. The next thing that I want to do is to give you a few examples of doing these problems, and in general, memorization of K is not recommended. We rather you find H, memorize H formula, but memorization of K formula is not needed. We go through the examples and we show you how to do them without memorization.
I'm rolling.
So we're continuing with completing the squares. Now we want to do an example. First example, f of x equal to x squared plus 6x plus 13. And so how do I deal with this one? First of all, what I need to memorize is h is equal to negative b over 2a. So basically, this is how it goes. F of x is going to be equal to, a is 1, so back to here, a is 1, x minus negative b, b is 6, divided by 2a, which is 2 times 1, then to power 2 plus k. Now, let's clean it up a little bit. F of x is equal to x minus, it comes up to plus, and 6 divided by 2 is 3 to power 2 plus k. Let's write down, and we found that h was negative b over 2, which was negative 3. Now, the next step is to find k. One of the easier ways of finding k is to plug back in h equal to negative 3 into the original value. So if I go back to the original, and find the y value for that, k is going to be equal to negative 3 to power 2 plus 6 times negative 3 plus 13. And it gives me 9 minus 18 plus 13, which is negative 9 plus 13 is equal to 4. So again, why did I do this part? Because I know h is going to be the x value of the vertex. If I plug it into the original, it should give me the y value of the vertex, and k is the y value of the vertex. There is, however, another method of doing this. So let's write this down. K is equal to 4. For h, I still say use this method of memorizing the formula for it. For k, there are multiple methods of finding it. One of them is this, to plug into the original, the value of h. H would be the x value. Is there any other way of doing this? Yes. Going back in here, I can compare these two together. So I have x plus 3 to power 2 plus k equal to x squared plus 6x plus 13. And then I have to expand this and compare it to here, and then solve for k. So that would be x squared plus 6x plus 9 plus k is equal to x squared plus 6x plus 13. That gives me k. Everything simplifies. And 9 subtracted from 13 is equal to 4. So one way, method 1, plug in. Method 2, expand and compare. So continuing with more examples of completing the squares. The first example was a parabola with the a that was equal to +1, and it would look like upward parabola, and then we found h and k, which gives us a minimal. Now this time I'd like to do another parabola, negative 2x squared plus 2x plus 4. This is with a is equal to negative 2, therefore it's a looking down parabola, therefore there is a maximum value over there. So again, the first thing that you want to do is to use the formula for h. And h is supposed to be negative b over 2a. And so find h. Negative b, which is negative 2, divided by 2a. 2 times negative 2. This gives me 1 over 2. So 1/2 is the h. Now, how do I find k? And to find k, method 1 is just to plug in 1/2 into here. And so I plug in g of 1/2, and I get negative 2. 1/2 to power 2 plus 2 times 1/2 plus 4. And this gives me a negative 2 times 1/4, which is negative 1/2, plus 1 plus 4. It's 5 plus negative 1/2. That is 9/2. So to complete the square, I have to write, this is the completing the square type, a, which is negative 2, x minus 1/2, and then plus 9/2. The method 2 of finding k would have been this other method. So this is, we found k this way. You would go ahead again and write g of x. So this is all solved. I'm just showing the other method. Negative 2 x minus h to power 2 plus k. And then you expand this and set it equal to that, and you solve for k. And that would be negative 2 x squared minus 2 times 1/2 times negative 2 over here, minus 2 times minus 1/2 times 2 times x, which would be positive minus x, and then 1/2 to power 2, which is 1/4, plus k should be equal to negative 2x squared plus 2x plus 4, and that would be negative 2x squared plus 2x plus minus 1/2 plus k is equal to negative 2x squared plus 2x plus 4. Again, we solve, and k turns out to be 4 plus 1/2 because all the rest will simplify, and 4 plus 1/2 is equal to 9/2 again. And then you rewrite it. So let's recap. You find h. You use either this method or this method to find k. And then it's important, this is the important part. Oh, this 2 is missing here. Important part of it is that you write down, you rewrite your g of x into the completed squared form. And that would be the a times x minus h to power 2 plus k. And again, since a is a negative value, meaning that I'm looking downward, the parabola is looking downward. That's a sad face. And the maximum is the at point 1/2 and 9/9 half. And so the maximum y value of the parabola is 9/2.